Moving on from Rolle's theorem, we're going to take a look at the mean value theorem. And the mean value theorem is actually one of the more important theorems in all mathematics, because what it suggests is that, similar to the mean value theorem, let's say we have a closed interval AB that a function f is continuous upon, and then the open interval AB for which f is differentiable upon. And essentially what it says is that there exists some number such that the tangent line is equivalent to the secant line. And we can see that in one of two ways. So we can use this formula right here, is that the derivative is equal to the secant slope. And you might remember that all the way back in the very first section, we started talking about secant slopes and approximations. And you can see that in this diagram over here. All right, so if we have a continuous function and it's differentiable, that means that there's some sort of slope there's some point to where the tangent slope, which is C, is equal to the secant slope that's intersected by AB. All right, so now this one's a little bit tougher, okay, just because we have to go through and do a little bit more work to be able to find the values for the mean value theorem if they do satisfy. So let's go ahead and see whether or not we can go ahead and use the mean value theorem. And then finally, let's see if we can go through and find the values that guaranteed on there. All right, so let's start off with a fairly easy non-polynomial function. And so we have this function x plus 1 over x, and we're given the interval -4 to -3. And we just want to see if the mean value theorem holds. And if it does, what are the values that satisfy? All right, so here's our conditions. Okay, so first of all, is it differentiable? Oh, I'm sorry, is it continuous? So is it continuous over -4 to 3? And let's look at our function. Our original function is x plus 1 over x. Well, what's the only value to where this is not continuous? All right, so it's only not continuous at x equals 0, right? Because we can't divide by 0. And this is -4 to -3. And 0 is clearly not an element of -4 to -3, right? So what that means is that it is indeed continuous from -4 to -3. So that's good, right? Now, what about differentiable? So what we need to do first of all is we need to find the derivative. And so that's going to be one of the things we could do is we could just set it up like this to take the derivative. And so the derivative is going to be 1 minus x to the -2, okay? Or that means that the derivative is 1 minus 1 over x squared. And what's the only number for where that's not differentiable at? Or in other words, where's the derivative not continuous? Well, we know that x cannot be equal to 0, okay? And clearly, 0 is not an element of -4 to -3, right? So once again, it is differentiable. So we can say f is differentiable over -4 to -3. All right, so you have to make sure, first of all, that the conditions are satisfied. All right, so those are good. And now what we can do is we go ahead and use the mean value theorem. Okay, so what that says is that there's some number that exists, some c, so that when you take the derivative, it's equal to that secant slope. All right, so in other words, we need to say that there's some value c such that f prime at c is equal to f at b minus f at a divided by b minus a. All right, and in this case, b is -4. I'm sorry, a is -4, and b is -3. And so what we're going to do is we're just going to substitute those in. And we already know what f prime is. Okay, so f prime at c, or f prime at x, is just going to be 1 plus or 1 minus 1 over x squared. We just found that. Okay. And that's going to be equal to the original function evaluated at -3. And remember, the original function is x plus 1 over x. So that's going to be -3 plus 1 over -3 minus -4 plus 1 over -4. And then we're going to divide all of that by -3 minus a -4. All right. Now, usually with Rolle's theorem, we just set this equal to 0. We set the derivative. Now we're setting the derivative now equal to the secant slope. So this is our secant slope, and this is our tangent slope. Okay, so we're just saying, where does the tangent slope equal the secant slope? All right, so now we just have an equation. So 1 minus 1 over x squared is going to be equal to, now let's compute this. All right, the good news is the denominator is just 1, -3 plus 4. In our calculator, we can just take -3, and then it was plus 1 over -3. And we're going to subtract -4 plus 1 over -4. All right, so we just do that in our calculator, and then we're going to hit math, enter, enter, so we can make it into a fraction. So that's 11/12. So it's not the nicest number, but could be a lot worse. So this is going to be 11/12 over 1. Okay, or that means that 1 minus 1 over x squared is equal to 11/12. We could subtract 1 from both sides, right? So, and that's just going to give us that. Let me go back over here. So we're going to subtract 1 from that, and that gives us -1/12. So minus 1 over x squared equals -1/12. We can multiply both sides by -1. So 1 over x squared equals 1/12. We could take the reciprocal of both sides. Okay, that's a legal operation to take the reciprocal of both sides. So that means that x squared is equal to 12. And then finally, we take the square root of both sides. So x is equal to plus or minus square root of 12. Or, remember, 12 can be written as 4 times 3. And so the most simplified version of that is plus or minus 2 roots of 3. Right. Now, let's get the approximation for plus or minus 2 roots of 3. So x is approximately, let's go in our calculator, 2 square root 3. And why does that matter? 3.464. All right. Now, that's a good thing, okay? Because remember the original interval that we were dealing with was -4 to -3. And clearly, -3.464 falls in that interval. But positive 3.464 does not fall in that interval, all right? And of course, with my math lab, we don't want to go for the approximations unless it specifically says so. And this one wants the exact value. So the exact value is going to be -2 roots of 3. Now be careful, if you input it as -√12, it might mark you wrong because you haven't completely simplified it. All right, so you want to make sure that when you put the answer in, that you write it in the exact value, okay, in the simplified term. So this is probably going to be the most simple version that we can. All right, and at Quim, this is good because -2 roots of 3 is an element of the given interval, -4 to -3. All right, so that's what we always want to check our answers, is that the mean value theorem guarantees that there's some number that falls in that interval that was originally given. All right, if it doesn't, then that means you have to start the whole problem over. Okay, so when you're answering this, the first thing you would do is you would say, yes, the function is continuous and it's differentiable. And then it's going to give you a part B, and it's going to say, what is the number or the numbers? And you're going to type in -2 roots of 3. All right, so we'll take a look at one more example of the mean value theorem, and that'll be it for this section.